Professor Hartman here this afternoon. Hope you're all doing fine today. This lesson today is going to be about chemical bonds. And from our earlier mini lecture, we discussed that the atom is made of a nucleus which contains the protons and the neutrons. And then around that nucleus in the different little orbits are the energy subatomic particles called electrons. Now today's mini lecture is going to be discussing three different types of bonds, chemical bonds. So let's take a look at our outline. We have three different kind of bonds. We have ionic bonds, covalent bonds, and hydrogen bonds. And then of course when we have two atoms bonded together, if they're different atoms, we can say that we have a compound or that we have a molecule. If we have two atoms that are bonded together and they're the same type of atom, then we just call that an element or a pure substance, depending on how many of those atoms that you have. For instance, if you have pure gold atoms bonded together, of course, then you have a nice, piece of pure gold. But if you have hydrogen and oxygen bonded together, you might then have water, okay, and the water molecule. So that's just a brief introduction to what we'll be discussing today. So what I've done, as in previous mini lectures, I have gone ahead and done some Google searches. And this first search, I was looking for covalent bonding. And as you can see, there's a lot of different things here showing up, but my interest for you today is for you to actually see what is happening when these electrons from different atoms, when they're actually bonding to make a molecule or a compound. So what we have is we have our hydrogen atom here, and the hydrogen atom has one electron, and it's zipping around in the orbits, or sometimes chemists will call these different energy levels or different shells. But for our purposes, we can use orbits. That's fine. So the hydrogen atom has one electron in its orbit, and the maximum number that will fit in this the hydrogen's orbit is, the maximum number is 2. 2 electrons will fit there. So the hydrogen atom is really full of energy because it's really wanting to fill its energy level, its orbits, and it will be attracted to another atom that has an orbit that needs to either borrow, share, or accept electrons from hydrogen. So what happens is carbon has 4 electrons in its outermost energy level or orbit, and carbon wants to fill that outer orbit with 8 electrons. Well, you might be wondering, well, what's going on here? You just told me that 2 will fill the outermost orbit. Well, that's hydrogen, and that's the outermost orbit that hydrogen has. But carbon, it already has the inner orbit filled, so it needs to go to the next level, the next what we call energy level, and it has 4 electrons spinning around out there wanting to have a partner. So what happens in covalent bonding is that the carbon has 4 areas where hydrogen can share an electron. And so what happens here now is carbon goes ahead and bonds with 4 hydrogens, and then hydrogen is happy because its outer energy level here is filled with the 2 because it's going to share with the carbon, the electrons from the carbon. So that's just a brief overview of how covalent bonding occurs. And basically the definition of covalent bonding is when electrons are shared between 2 atoms. So we have a sharing here of electrons, okay? Sharing. So that's just one example on this page. There are others. We have this one here shows a little bit better of how this inner energy space here, this energy level is filled with the 2 electrons, and then you jump out to the next energy level or the next bunch of orbits that are out here where the electrons are zipping around. And you see that there are 4 when there's room for 8. Okay, so I don't want you to get too overwhelmed by that, but I do have to explain that this is how bonding occurs. And once again, this is covalent bonding. It is the strongest bond. Our next type of bond is an ionic bond. Now, an ionic bond occurs when you have 2 atoms that need to have the outer energy level here. They have to have it filled. And what happens here is we have in chlorine, for instance, we have 1, 2, 3, 4, 5, 6, 7 electrons. Well, it only needs 1 more electron to be a happy atom and to be filled and to be balanced. So what happens is sodium has, it's not showing it here, but originally it does have 1 electron in the outer orbit here. Okay, and what happens is this electron, when sodium gets close to chlorine, that electron bounces over and is donated to the chlorine so that the chlorine is happy with all of its electrons in the outer shell here, 8 of them. It's very nice. And then sodium is happy. It's got 8 electrons in the outer shell there. So what happens now is that because we have 1 less electron than there are protons in this sodium atom, that sodium atom becomes positively charged because there's more protons. Now, because now chlorine has 1 more negative electron, than it does positive protons, it is now negatively charged. So these two are attracted to each other now by an electrical charge, an electrical positive negative attraction, and that's what ionic bonding is. So ionic bonding is the attraction or the bond that forms between oppositely charged atoms. And these atoms now, since they do have a charge, these atoms are called ions, and therefore an ionic bond. There are other diagrams to show you this type of a bond. So you can move through and look through some different websites, and if you have any trouble understanding that, you can read more about that. The next type of a bond I'd like to discuss today is the hydrogen bond. And this is a bond that occurs between the different hydrogens in the water molecule. First, we have our covalent bond, okay? And this is occurring between the hydrogen and the oxygen. Then we have, if we do have a group of water molecules, I'll show you this one, maybe that will show, okay? What's happening here, I believe what this is trying to show is these two red dots here are hydrogens, and this is a oxygen. And what happens is the positive area on the hydrogen molecule is attracted to the negative area on the water, on the oxygen part of the water molecule. So this is a very weak bond, and you know, it will continue to form throughout several different water molecules themselves to form water, to hold water together. Okay, hydrogen bonds as a group are very strong, but individually hydrogen bonds are very weak. So hydrogen bond is basically a bond between a hydrogen, the positive area of a hydrogen molecule, and the negative area of the oxygen in another molecule. So that's basically, in water, that's how hydrogen bonds work. Okay, so I hope you have enjoyed your lesson today on bonding. Until next time, have a nice day.